power-ups. Today, we're going to level up our game. We're moving beyond the basics to turn those fragile queries, the ones that break at the worst possible moment, into solid professional code you can actually count on. Let's dive in.
Come on, you've been there, right? You spend all this time crafting the perfect query. It's beautiful, it's complex, it runs flawlessly on all your test data. Then you push it to production, it hits one weird value, and poof, the whole thing just crashes and burns. It's so frustrating, but that's exactly what we're tackling today. So, what's the big bad culprit here? A lot of the time, it's something that looks almost silly, deceptively simple, like this ticking time bomb trying to divide by 0. I mean, think about it. You're calculating, say, average sales per employee. But oops, someone just added a brand new department that doesn't have any employees yet. Your query hits that one row, tries to divide by 0, and boom, the whole script just grinds to a halt.
And here's the really important part. This one little line of bad math, it's not just a local problem. It doesn't just affect itself. No way. If that query is nested inside a big script or a stored procedure, that single division by 0 can take the entire process down. A total showstopper. We've got to have a way to see this coming and handle it, gracefully. And that's where this amazing safety net comes in, the try-catch block. Seriously, just think of it like you're talking to SQL. You're saying, hey SQL, I want you to try running this piece of code. Full disclosure, it might be a little risky. If anything goes wrong, for any reason, don't just panic and crash. No. Instead, I want you to calmly jump over to this other section, the catch block, and just do what I tell you to do there. It's really the heart of what we call defensive programming. You're anticipating what could go wrong, and you're making a plan for it.
Okay, let's break down how this thing is built. It's actually super simple, which is what I love about it. You just wrap your risky code, your potential troublemaker, inside a begin try and an end try. Then, right after that, you lay out your backup plan inside a begin catch and end catch. Now, if the code in your try block runs perfectly, no problems, then the catch block just gets skipped over completely. But the second an error pops up, SQL immediately stops what it's doing in the try block, and boom, it jumps right into the catch block.
So this is the exact ugly error message our little divide by 0 problem would spit out. But the cool part is, inside your catch block, you can actually grab this message using functions like error message function. And once you have it, you can do anything you want with it. You could log it to a table for later. You could show the user a much friendlier message. Or you could just tell the script to keep calm and carry on. The main point is, you are now in control. The errors don't control you anymore.
And this is where you really see how powerful this is. It's not just for your math headaches. I mean, what if you do something silly, like accidentally try to multiply a salary number by an employee's name? That's a classic data type mismatch, right? Well, try catch snags that error too. It prevents the crash and lets you handle it on your own terms. It's incredibly versatile.
Okay, so we've bulletproofed our code. It's not going to crash on us anymore. That is a huge win. But robust code is really only half the battle. The next big challenge is making sure the data itself is clean, consistent, and predictable. So let's switch gears a bit. It's time to talk about taming our numbers.
Just picture this. You're putting together a big financial report for your boss. You absolutely cannot have weird rounding or random decimal places all over the place. You need precision, right? Well, the good news is SQL gives us some awesome tools to enforce that precision and get our numbers standardized before they ever make it into that final report.
So let's look at two of the most essential functions for this job. I like to think of it as a rounding duel. We've got floor on one side and ceiling on the other. They might sound kind of similar, but trust me, their behavior is the exact opposite. And knowing which one to use and when is totally key. And honestly, it's pretty much as simple as it sounds. Floor looks for the floor. It always rounds down to the nearest integer, no exceptions. And ceiling? It looks for the ceiling. It always rounds up. The direction is totally fixed. It doesn't matter what the decimal part of the number is.
All right, let's see these two in action. With positive numbers, it's totally what you'd expect. 25.25, 25.97. Floor gives you 25, ceiling gives you 26. Easy. But now, look at the negative numbers. This is where you got to pay attention. The floor of negative 2550 is actually negative 26 because negative 26 is the integer below it on a number line, and the ceiling is negative 25, which is the integer above it. Now, this might seem like a tiny detail, but for things like financial calculations, especially when you're dealing with debt or negative balances, getting this right is absolutely critical.
All right, let's wrap this up and bring it all together. What do we actually add to our SQL toolkit today? Well, we've got two really powerful concepts that honestly work hand in hand to make our code so much more professional. Think about it. We've gone from a world of chaos where one single bad value could bring your whole workflow to a crashing halt, to a world of control. And this is so much more than just writing code. It's about a mindset, a professional approach of defensive programming. We now have the tools to tell SQL exactly how our code should behave when it hits an error and exactly how our data should be cleaned up and presented. So if you remember anything from this, remember this. 1. Use try catch. It's your safety net to stop errors from crashing your scripts. 2. Use floor to always round down. And 3. Use ceiling to always round up. If you can master these simple tools, you're going to be writing way more robust, way more predictable code, I promise.
And that brings me to one last question for you. You can now control errors. You can control numbers. So think about the data you deal with every single day. What's the next bit of chaos you need to get under control? Is it messy text strings? Is it all those inconsistent date formats? The great thing is, the principles we talked about today are exactly the same.